Right. Welcome everybody to another edition of the PIBBSS Speaker Series. Today it is my pleasure to welcome Abram Demski, who I've had so many wonderful, beautiful interactions with over the years. Abram is working on agent foundations at MIRI, of the embedded agency flavor, if you're familiar with that. I like to joke that the zeroth law of embedded agency is that Abram Demski has already written about whatever you're trying to write about in 2018 or so. Yeah, without further ado, Abram, do you want to share your screen?
Okay. Hopefully that's working.
Yep, that's great.
Cool. Okay. So, yeah, and likewise, I want to thank Sahil for dozens of hours of conversations, which helped me clarify some of these ideas. Although, of course, this is my perspective, not Sahil's perspective. I make no claim to speak for Sahil. Is the sound working well and everything?
Yeah, I'll also say, Abram, if you want to share how you'd like the questions to be, I think you mentioned you like it to be highly interactive, but if you want to suggest it to
Yeah.
the participants today.
Yeah. So for me, I don't care if I get up through all the slides. I'd rather have a lot of discussion. Um, the the math is loaded towards the end of the slides. So if we don't get to the math, it's all in the post by the same title from December on lesswrong. Um, there are some slight notational differences, but it's basically the same thing as in the post from December, but with a much different motivation explanation than the one in the post, which is kind of going to be the focus of the talk. Um, so yeah, I guess I'll get into it. But yeah, I want every people to jump in as much as possible, basically, with questions and comments. So the general plan is to shed light on the concepts of meaning and agency using the newish concepts of legitimacy and endorsement with hopeful applications to mitigation of existential risk from artificial intelligence. And the very short version of the talk is that endorsement is the willingness to take some conclusions from some other process as your own conclusions. And legitimacy is to endorsement as goodness is to utility. So uh, legitimacy is like goodness kind of relative to like human morality or some circle kind of like that. Whereas endorsement, like utility, is more a agnostic general concept of agency. Agency is defined here as endorsing something for some purpose. So if somebody is a really good Tetris player, then I would, if I was trying to play Tetris well, I would endorse their moves as like better than my moves for the purpose of playing Tetris well. And then the analysis of meaning that's going to be here is um, agentically performing what's called reference maintenance, which means maintaining some kind of map territory correspondence. So I'm going to pause for questions just so that somebody says something, please, so that we have an affordance to interrupt.
Maybe, Abram, can you give some examples of what you mean by endorsement, just so I get a sense of where
Yeah,
you're after?
so the kind of the primary motivation here is like um if I have an AI that's supposed to be doing some kind of work for me, then I endorse its output as like doing a good job on that task that I have set for it. Another example of endorsement would be like uh if I kind of um I trust my own reasoning, so I might not know, like, let's say I have just started to think about the task of filing my taxes this year, and I don't know how I'm going to fill in all the fields, but I endorse my process for figuring that out. And so, like, I'm happy for physics to kind of substitute my current thinking with my later thinking. I think that this is a legitimate thought process that will result in conclusions that are at least better than the idea that I initially have as to how to file my taxes this year. Something like that. And another example would be if I have a close friend whose opinions on matters, maybe let's say politics, I really do take into account. So if I say something and that person is like, whoa, Abram, you've gone over the deep end. Your views are really too extreme here, then maybe not in every case, but in some cases, I'm like, I sort of take that opinion for my own. I'm like, well, I endorse this person's reasoning, so I take it seriously and I substitute their opinion for my own in the cases where they're very forcefully like, whoa, Abram, you're really wrong here.
So I have another question.
Yeah,
So would it be appropriate to say that a reasoning process is legitimate if it's good for us, or maybe like for humans in general, to take its conclusions for our own?
yeah. That's the kind of thing I have in mind here. So like an example of legitimate reasoning in my head is like logical reasoning. Like we're pretty sure that logical reasoning works. Um, there's some, serious questions in the deep foundations of logic, but by and large, like a logical chain of thought, we should just take that seriously, even if the result seems surprising. And so that's the kind of thing I have in mind, but it's sort of like at, at least in the direction of moral realism here, where it's like I'm not just talking about like necessary logical truths. There's legitimate reasoning also for morality, also for what I should do in a particular case, and what it means for it to be legitimate is that I should accept its conclusions.
Right, thanks.
I would be better off, in some sense, accepting its conclusions.
I also want to ask, so if the third line is defining agency, are you also implicitly defining an agent?
No. This is sort of agency as a mass noun in a way, like uh at least there's nothing in these ideas so far that sort of draws a boundary around this is an agent that's making this decision. The agency is more like, well, somehow there's activity, like say Bob takes an action. So Bob like turns his car at the turn signal. And or yeah, but like Bob, or maybe let's say Bob stops at a traffic light. The activity in the world of Bob stopping at the traffic light can be agentic, but the the kind of theory that I'm building does not yet say very much about like where that came from, like drawing a circle around Bob as an agent who made that decision. So I'm kind of talking about decisions as agentic without saying very much yet about what the agent is who kind of makes that decision.
Cool. Yeah. Thanks.
So the ambitious goal here is to get something like a metric for friendliness. So I'm using this term friendly AI because I think I want to invoke these intuitions of like not like alignment, though I don't like disagree with alignment as a way of describing things, but friendliness more invokes the kind of concepts that I'm thinking about here of like I want to develop a better mathematical picture of kind of two agents that are being friendly with each other in a somewhat symmetric way. And I'll say more in a little bit about why I think it ought to be symmetric. Um, and when I say metric, part of the reason that I said metric is because loss function kind of invokes the wrong concepts. Since if we plug a loss function into an optimizer, then the loss function is kind of ignoring like where these answers came from and just scoring the answers in themselves. And it seems like for our purposes, we really need to pay attention to all of the agency in the room, so to speak. So we need to know not only like how well some kind of answer scores, but also how we got that answer in order to know whether or not we trust it, because we're worried about things like manipulation. And so this metric is not something that the machine learning algorithm performs gradient descent on necessarily. It's something that we have to evaluate. It would be nice if the theory resulted in a metric which allows us to have a story where we can trust a loss function with a generic optimizer attached to it, just because that's the shape of modern machine learning. I don't want to rule that out as a possible thing that could come out of this theory at some point, but uh, that's not the obvious result. Yeah.
Uh, so is the idea that you're working towards some metric and you think like, okay, maybe this metric is good enough to like say whether an AI is friendly with respect to us or how much, but it's not good enough to just optimize this metric and get a maximally friendly AI because it's like not a perfect concept yet.
This is close, but I feel like that's like maybe a little bit off. Certainly, we're not going to have perfect concepts, whatever that means. But it's more of a like the picture I have in mind is one where we have concepts that are good enough that we have this metric, and what we can do with this metric is that if we have bounds on how we reason about a system, we analyze it, we get bounds on how good it is with this metric, because the metric is not going to be something we can directly measure. We can't directly measure like the goodness or legitimacy of the system, but we can get strong enough of a theory that we can get bounds on this. And then those bounds tell us that that system has certain safety guarantees. Does that kind of answer your question?
I think a bit, but not quite. So like what would go wrong if we try to like maximize the lower bound of this metric?
I think that what would go wrong is more that like this metric is not necessarily directly measurable. It's
Uh-huh.
something that we might have to do some theorizing about to get bounds. If
Okay.
if we could automate that theorizing, then great. But that's kind of what the metric is trying to do for us, is to tell us how we can automate such reasoning, right? Like this reasoning kind of will invoke general, like legitimate reasoning, general scientific or engineering reasoning, whatever you want to call it. And so it's like if the AI itself could reason about this bound in a sufficiently trustworthy way in order to make itself safe, then like great. But in order for that to happen, we would have had to do some reasoning beforehand to know that we trust that reasoning, which means we have already scored it in some way to say that it's good enough that we're okay with it being the one to do that reasoning.
Okay, I
And
think
the theory of how that all could work is the thing that I'm trying to work out. Okay. Um, and then another thing to point out here is this isn't like I'm not talking about like the outer alignment problem. This theory would need to encompass both outer alignment and inner alignment. And so this, as I've been emphasizing, this metric needs to encompass not just some kind of output of a system, but also like how we get there, what kind of optimization process is producing that output, and why do we trust it? And so on this plan, the distinction between inner and outer alignment probably breaks down. And as I said, it's not something that's even necessarily directly measurable. It's something that we can put bounds on, something we can reason about, some kind of an idea that lets us derive some appropriate notion of bounded risk. But whenever we try to come up with something like this, there seems like there's this like a few clusters of problems that crop up reliably. That whenever we try to come up with this, we get perverse instantiation or specification gaming or Goodhart problems, which means like our notion is going to be imperfect. And so when we try to drive things to high numbers on this notion, then we're going to get something that's not actually what we wanted, because there's uh, going to be sort of bad portions of our metric. And although the bad portions might be rare on average, if we drive for very high values of the metric, what we kind of expect is that high uh, we get high by hitting error patches that are high. And this is kind of like maybe the most general kind of statement of the problems that we get. And then a particular variety of this is wireheading, where you hit places where there like the analog of a reward signal can be corrupted. And I want to make the argument that wireheading is in the same cluster as human manipulation. Does that make sense to people? Like in the stereotypical wireheading case, you have some reward function which is giving feedback to a reinforcement learner but this is like an actual box, so to speak, like an actual calculation that's being performed in the physical world. And if the reward learner were to understand this and understand its goal as get this box to produce high outputs, then it would want to corrupt the calculation inside of the box. And human manipulation is really just kind of the same problem, except the system identifies the human as the box. And so it sees its goal as to get as much approval as it can from the human. And then we get a very similar cluster of problems from, I don't know how many people read the eliciting latent knowledge document. So this was a proposal from Paul Cristiano about how to improve our ability to trust AI by trying to understand like what is its reasoning. But he talked about a number of proposals that face difficulties, and it seemed like repeatedly a sort of problem that crops up is that you want something to take human feedback and sort of generalize it appropriately. But one possible generalization that you can never hope to kind of eliminate with the feedback itself is the actual physical theory of what's giving the feedback, namely, some human is somehow arranging for this feedback. And so a hypothesis that you can't eliminate is the hypothesis that just simulates the actual process, simulates the human. And then you get this same kind of problem of like, you're going to get wrong answers because you're hoping it would extrapolate the human reasoning in what I want to call a legitimate way, extrapolate the human reasoning kind of in the way that we intend, which is very ambiguous and unclear, but there's some kind of intention that we have. And instead, we do human simulation, and the generalization that we get is, oh, whatever the human would have said if the human had said something about this example. And then this gives us wrong answers, and we get bad behavior from the system.
Can you say more about why you
So,
give us wrong answers?
I mean, it gives us wrong answers because humans are fallible, right? So it's like, example, if somewhere in a system you're trying to solve inner alignment by teaching some kind of module to look at another part and tell us whether there is an inner optimizer there. And you've given up on some sort of grand theory that would just look at arbitrary neural networks or arbitrary source code or whatever and tell us whether there's an agent hiding inside. Instead, you're like, well, we're going to do the best we can with machine learning. So we take this module and we hope to make it like very, very intelligent so that it can eliminate actually almost all of the problem. But we have to train it somehow. And we can only train it with examples that basically humans have labeled somehow, right? With our limited understanding of when there are agents hiding inside of a hypothesis, hiding inside of a neural network or a computer program or whatever. And so you have humans labeling, like humans going in and looking at, okay, does there seem to be anything dangerous here? And we have like the bucket of safe looking ones and the bucket of dangerous looking ones. And we feed it into this module to try to train it. And the hope is that this module learns to actually label things better than the humans do, right? Like what we want is for this to become a very smart differentiator of whether a hypothesis has some dangerous agent hiding inside of it. But the kind of human simulation problem in this example is that we can't eliminate the, like, by virtue of this kind of data that's been labeled by humans, we can't eliminate the hypothesis in this module where this module is just doing human simulation to label these examples. And the problem with this hypothesis is that it's not going to do any better than the humans.
But
Won't.
say if it simulates you, Abram, won't it also simulate you saying this will be a problem? And then therefore, like are you saying that a sufficiently high fidelity simulation will not be able to replicate this sentence of yours? Wouldn't it replicate this sentence and therefore reverberate, and therefore we'll be fine? ...
If the type signature of the module that I'm training is I put in a hypothesis and it spits out like a safety score of some kind for that hypothesis, such that it says it's unsafe if there's an inner optimizer, and it says it's safe if there's no inner optimizer, and this is just a legitimate hypothesis. Then in that case, it kind of doesn't have room to sneak in this message that's this warning that Abram would give of like, hey, I don't know. I this the analysis of this program was beyond me or whatever. Now, of course, we could consider a version where it does have this affordance to spit out this message. So maybe like, I mean, the simplest case would be it has some third value it can spit out that's like, I don't know. I don't have a direct response to, okay, what happens in this case, but my
Maybe
sense
something
is
you
that
can...
the same problem is going to kind of creep in that always seems to creep in, right? Like what we actually needed the module to extrapolate beyond, like to take the kind of analysis Abram was doing, but to scale it up, because we were not just trying to automate an Abram, we were actually trying to increase the capability so that we could differentiate safe or unsafe for enough hypotheses that we could get something done. And so, like, kind of what I'm trying to do by providing some amount of formalism for legitimacy, or at least endorsement, is kind of characterize what we mean when we say, well, we actually want it to extrapolate correct reasoning from the limited examples that were provided. We don't just want it to learn an Abram simulation, because Abram simulations are notoriously fault. You can only do as well as an Abram if you have an Abram simulation.
Yeah, I'd love to discuss this more. Like, I think we might have some disagreement or something, maybe after the talk.
Hmm. Yeah. So my kind of third bullet point here is a bit fuzzy, and I think we kind of already brought up a version of it, but it's like sometimes it feels like the only solution here would be some kind of whole perfectly accurate model of the world plus a whole perfectly accurate model of human preferences, whatever that would even mean. And that would be the only thing that would allow us to properly bound the risk of an artificial intelligence by just actually like extrapolating what is this AI system going to do in the future, and how good or bad is that expected to be. So the general thing that we're trying to do here is somehow shortcut that obviously infeasible project. Somehow we want to figure out a way that we can like trust the AI itself to be doing reasonable things in response to situations. And the concept that I'm bringing in here to try to do that is this endorsement concept. So understanding sufficient conditions for endorsement could help us build systems whose actions and reasoning we can justifiably trust, particularly if those sufficient conditions are actually feasible, which is, of course, another question And then if perhaps some of those conditions seem infeasible, then understanding necessary conditions for endorsement could help us rule out systems as untrustworthy and perhaps establish important impossibility results. And you might say, but Abram, why is this concept of endorsement any less nebulous and more helpful than any number of other impossible problems that we could name, whose solution, if only we could obtain them, would help us get some progress on AI safety? My main answer is, I don't know, maybe it's equally impossible to all the other impossible problems. But I do feel like there's something new here, at least in my personal understanding, that might lead to some progress. And the sort of more detailed answer number two is, well, yeah, I have some specific intuitions about how this might go. We'll see if they have any utility. But first, we come up with an adequately rich mathematical picture of agency that is of the intentional stance, what it is for an agent to regard an agent as an agent. Then a representation theorem, which allows us to interpret agentic systems, that is, interpret systems that seem to perform well in the world, as having beliefs and goals. And this is kind of like it's unclear that all systems that do perform well do actually sort of have beliefs and goals in their calculation, right? Like sometimes there's just like a policy that works very well that can't be exactly be said to be calculating beliefs. But my intuition is, well, it still works for some reason, right? A policy that works well for achieving some goal, there will be reasons why. So maybe it doesn't actually sort of physically calculate beliefs, but we can at least interpret it, do a little bit of interpretive work and say, well, it's as if it believed such and such. And this as if story explains why it seems to work. And then we also want some kind of theorem to characterize when one agent can justifiably trust another. And this is, of course, the concept of endorsement that I've been going on about. And then having all of these things, maybe one route to getting an answer from all of this is we might be able to use this for retargetability. So once we are able to interpret a system as having separately beliefs and goals, then we can take the beliefs that justify this policy that works, but not take the goals and somehow like make a new system like this other system we weren't able to trust. We make some new system out of that we can trust. So this is sort of a strategy stealing idea that we should be able to like maybe not all general malign systems because some of them will be like uninterpretable up to us somehow, but maybe we can figure out necessary and or sufficient conditions for these systems under which if these conditions like under which conditions we can get this strategy stealing. It seems like I'm spending a lot of time trying to carefully articulate what it is I'm trying to do. That's the talk. We're kind of several meta pushes down of like trying to figure out what it is that we're basically trying to do. And the hope is that computation eventually terminates and reaches return clauses instead of just recurring always. But so I mentioned that I wanted to use the term friendliness because it sort of invokes the correct intuitions that I'm trying to get at better than the term alignment. And I feel like this concept of friendliness involves kind of letting somebody in. Like you could say, like, when you have a close relationship with somebody, you really like in some way give them access to your reinforcement buttons, although that maybe that's not the greatest metaphor. But there's some way in which like you let them into your reasoning. And this seems somewhat contrary to the sorts of strategic manipulative interactions which naturally pop out of existing rational agency frameworks. And so I have this diagram of kind of what we're after, where the artificial intelligence has corrigibility with respect to the human, or really this should have been the plural, humans. So the artificial intelligence really kind of pays attention to the feedback provided by the humans. But also then symmetrically, the humans extend trust to the AI, right? And this is because like, if I say like humans should be corrigible to AI, this sounds kind of weird, but well, humans should be able to trust AI. And what does trust mean? Trust means that we take the AI's reasoning as legitimate. We take the AI's reasoning as something we can just substitute in for our own reasoning. And that's kind of the same thing as the corrigibility arrow. So it is kind of a symmetric picture. And that's kind of the picture that I'm trying to build up. So this concept of corrigibility, kind of the consensus that has grown, is that it's like very unnatural in the rational agent frameworks that we have. But I think that there's a lot of room opened up by radical probabilism and I don't know if everybody has what radical probabilism means in their head. This talk isn't really a talk on radical probabilism, so I don't know how much time I want to spend on that, but it's sort of the water that I'm swimming in. This is all like in a radical probabilist context for me. And one feature of radical probabilism is that, like, as long as you're not dogmatic about something, that is, you haven't assigned probability 1 or 0 to some proposition, any belief transition could be legitimate. And I could transition from any beliefs to any beliefs just because I like thought about it and that's what I decided. And that's not in itself irrational. Things only become irrational because of a bigger picture. Like we still have rationality rules that apply, but they apply kind of only in expectation. So we don't necessarily require like Bayesian updates, for example. We don't always update in the Bayesian way. We could update in other ways, but we call something irrational if it's not Bayesian in expectation. And
I have a question. I
yeah,
don't quite see how value change fits into this. Like, do you mean that
great question.
do you mean that if we have like an AI which is like radical probabilist, then its beliefs may change in a non-dogmatic way, like its beliefs about our values, what we want it to do, might change in a non-dogmatic Bayesian way? Or do you mean that if you have like a classic VNM rational agent, and you tweak it such that it's no longer classical Bayesian but radical probabilist, then it can change its values?
So it's kind of like I have my own picture of radical probabilism that I haven't like quite managed to write down anywhere yet. And in this picture, value change is just like the same thing as belief change. So there was this paper of Skirm's where, so like radical probabilism, as I've described it in my big post on radical probabilism, is just about beliefs, right? And so you might still imagine some kind of fixed utility function, and you might still imagine the same kind of like classical Bayesian ideas about like it's never rational to change your utility function. But you can think of beliefs, and this is the thing that Skirm's paper does, is you can think of beliefs as just a special case of expectations in the sense of like an expectation operator, um, where the expectation is about a variable that's either 0 or 1, right? It's either true or false, and the probability gives you the average value that you expect for it. But you can open it up to general real valued variables and say, well, a belief doesn't have to be about a thing that's true or false. We can have this more general notion of expectation that's about something that we think of as having a general real value. And then what you can do is imagine that utility is such an object. So instead of having, I had this post unorthodox case against utility functions, where I basically waxed poetic about the Jeffrey Bulker framework, and how in the Jeffrey Bulker framework, you don't have utility functions in the sense of being able to assign a number that tells you the preferability of a world, where a world is this kind of, I've specified the value of all the propositions, which is kind of an infeasible object to imagine that we have access to anyway, because we don't have this kind of true description of the world to even like assign these numbers to. And then even if we did, it would be something like quarks, and like we would need to write out an entire description of where all the particles in the universe are and what momentum they have, and then assign a utility number to that, and that just is crazy. And so instead we think of preferences as being codified by these expectation operators, which take as input not worlds but events or propositions, right? And so we have the expectation of a proposition, and you can think of this as like the conditional expectation of some real valued thingy given that proposition. And so then in this world, or in this ontology, it's not even clear what kind of shifting around of expectations counts as value change versus not value change, because the default is if more information comes in, then these values are going to shift around in response to that information anyway. Like my expectation operator on events should change when I get more information, right? But you could say, well, the value change is when it does this in a non-Bayesian way. So when it the new expectation operator is not simply the old expectation operator conditioned on this proposition. It changes in some more free-flowing way, in exactly the same way that probabilities are changing in some more free-flowing way in radical probabilism. And so, yeah, does that make sense? That's where I see value change coming in.
Yeah, it's super interesting. Thanks.
And so values become just like probabilities in the sense that I can develop more refined probabilities just by somehow thinking longer and changing my opinions. And often this will be in an endorsed way, meaning I think that the probabilities that I have after thinking longer are going to be predictably better than the ones that I have before thinking longer. And our values are just exactly the same. They just change around. And I want to make the point that this does not negate a kind of realism about like you can still imagine that there is some kind of true human utility function, but it's just not something that we computationally have access to. It's more like this limit of like what we would think if we were able to think longer and longer under conditions that result in legitimate reasoning, meaning like we we aren't drugged, we aren't wireheading ourselves, we aren't um deprived of evidence to the point where we go crazy because we're reasoning in a vacuum. And so you can still imagine, and I think it might even be that there's like a theorem that rational agents should kind of imagine in this way, that there is this like uh this sort of true value that you're just trying to figure out. Because as you think longer and your values shift as a result of thinking longer, you always think of your new beliefs as better than your old ones. Uh, I mean, that's not literally always true of humans, but under certain rationality assumptions, it's going to be true. And so you think of yourself as making progress towards some sort of moral truth or something like that, at least with respect to your own preferences and perhaps also intersubjectively.
So does that assume um like because you could distinguish between cases where you have convergence like within a single person or like a single agent can try to like the various kinds of like reflection on their values and thinking longer about their values and beliefs, and maybe all such legitimate reflection processes would eventually converge to the same like true utility functions in quotes, or that there's like one convergent utility function for all of humanity, excluding psychopaths and so on, or like that there is some like broader but kind of natural class of all agents that has this one convergent true utility function. How do you think about these things?
Yeah, I mean, I think that there will be mathematical pictures at various points along the spectrum. I think it makes sense to think about so I'll go to the extreme end and illustrate how I might argue for that. And then we can kind of back off for sanity purposes or something. So in the extreme, this like all agents should, with a capital S, converge to some true utility function. Um, I think the kind of case to make for that is through like, well, two agents in conflict, they should make Pareto improvements, right? There's they're just both better off. They ought to do that. And they ought to do that through like reasoning about each other and figuring out what kind of handshake they can reach. This is not to say they should make any Pareto improvement, because some are unfair, right? So there's some kind of a like bargaining process between all agents. I don't know if you're familiar with like multiverse wide coordination via super rationality kind of ideas. Um,
Yeah, a bit.
and so it's like within that picture, we could say, yeah, there's this like way in which all of the agents should arrive at this bargain. Now, we could think of them as arriving at this bargain, but still having their individual values. And like, in some sense, that might remain a viable view. But once they're at the Pareto frontier, then we can think of them as one agent, right? Like that's like the math of agency that we have, which, you know, perhaps we should throw away, but like the math of agency that we have is through this idea of Pareto improvements, getting to the Pareto frontier, and then you can like draw this separating hyperplane that lets you think of this policy that's at the Pareto frontier, that's the joint policy for all of the actions that have been coordinated, as coming from one utility function that's being optimized. And so, and similarly, if we end up like close to the Pareto frontier, then probably we think of it as some bounded rationality, right? And so at the end of that process of these agents having coordinated with each other, they have, in a certain sense, become one agent with one utility function. And we can think of them this way, and like perhaps to some extent, that's how we should think of negotiation as resulting in value change, as resulting in like letting others into your own reasoning to come up with a joint strategy. And as a result, you've converged in your thoughts on what is good or what is useless or what is legitimate. Now, that's probably like you said, like minus some sociopaths. Like if somebody is literally negative of all your preferences, then you're not going to be able to make a deal with them, right? So it's not going to be literally all agents. And probably there's a lot more caveats that we could add. But yeah, that's my kind of the extreme case for there being kind of one true utility function for all agents. And then we can back off from there.
For now, it sounds to me like it's less about one true utility function for all agents, but more like being somewhat small-ish manifold of possible or like acceptable utility functions that are like viable as bargaining solutions.
Yeah, in some sense, I don't think like uniqueness is that important to my story or something, but I'm not sure quite how to talk about that yet. Like, yeah, there could be many viable bargains that would be reasonably fair and so on. So now we hit the actual math slides. Yeah, any other questions before we dive into this stuff?
If I missed everything you said so far and wanted to jump in from here to pay attention, what would I need to know?
Well, I can just start again at the beginning. Yeah, I'm not sure.
Just maybe like 2 lines to
Right.
contextualize the math or something.
Okay, yeah. So what I'm gonna do here is I'm gonna start with this thing called the reflection principle that's like been discussed for some decades. And then I'm gonna start modifying it and kind of generalize from there to this concept of, well, to multiple concepts of endorsement that I think are relevant to these thoughts that I've been having. And so the goal is to start with this thing that's kind of in the direction, and then I will give several mathematical formulae for potentially interesting concepts to this theory of endorsement. But before I dive into that, let me complain for a minute about how terrible the name reflection principle is. Because as I was researching for this talk, it caused me so much pain Googling things. Because there's like 6 different things at least that are called reflection principle across science and math and philosophy. But anyway, so yeah, the reflection principle is this simple idea that like our beliefs now, if we think our subsequent deliberation is rational, ought to have the property that, conditioned on the outcome of this deliberation being a particular probability for a particular proposition A, our current probability for A should just be that value. So this is a notion of us kind of deferring to our own future opinions, trusting our own future reasoning. And I would argue that this is like more basic than Bayes' theorem as like a relationship between opinions across time. But over the years, there have been counterexamples and counterarguments offered. I'm not really endorsing like the reflection principle itself as like absolutely true. One counterexample is as follows. So like I remember what I had for lunch today, but I anticipate that some years from now I will have forgotten. I would say 1 year from now, except I'm specifically using it as an example for this talk, so maybe I'll remember it longer, of course. But uh, so because we forget things, then obviously we don't trust our future opinions about those things that we've forgotten more than our current opinions. We think our current opinions are better. So it's not always the case that the reflection principle applies, but it does seem like kind of clear there's some kind of case, there's some like, so long as we don't forget things or something like this, where the reflection principle applies. And what I want to do is basically say, well, this case where it does apply, that is my central example of endorsed reasoning, right? Like if I'm like gonna take a bunch of drugs or something like this, particularly depending on my opinions about what psychedelics do to you, of course. Like if I'm about to take a bunch of drugs whose impact on my cognition I do not trust, then I will think that the reflection principle is false. And to me, the significance of this fact is I do not endorse that reasoning process. I do not endorse the reasoning process, take a bunch of drugs. Or if I'm going to wirehead myself, I'm anticipating it to change what my um, sort of behavioral apparent preferences are in a way that I do not endorse, that I do not think of as legitimately reflecting my preferences. Unlike other kinds of value change, which I may endorse, like if I become a connoisseur of a particular kind of like soup or something, and like there might be a real way in which I've gained preferences about this like soup that I did not have before. Before I tried this soup, I didn't have any sort of real preferences about it in some sense, but I have gained those preferences, and I think that process is legitimate. I don't think of myself as having like wireheaded on soup or something, at least potentially as an example. And so there's kind of legitimate reasoning processes, legitimate value change, and then non-legitimate and yeah. And so this is sort of turning around the reflection principle and saying, well, I don't think it's always true, but I want to focus on whether it's true or not and name that endorsement. So here we have our first definition of endorsement, which I'm calling belief endorsement to distinguish it, which is just that probability distribution P1, belief endorses probability distribution P2, precisely when we have this relationship that P1's opinion of A conditioned on P2's opinion of A being X equals X. I put the quotation marks in red because they are syntactically tiny, but I think they have a larger significance than that. So why I put these quotation marks around there is to remind you that this is like in the internal representation of P1 rather than the meta language that we are writing in. So there's a translation here that's very important. So we have a translation of statements in our meta language, namely like P2 has an opinion of A that equals X, or like the probability that P2 assigns to A is X, has been translated into the event space of P1. And what this is doing is assuming that we know how to translate between the ontologies or event algebras or propositions of P1 and P2. So if we imagine that P1 is Alice and P2 is Bob, this is like Alice has events in her event algebra corresponding to like Bob believes such and such. Or to put it a different way, Alice might have like a, let's say, like a physicalist view of the world in which there is a physical thing over there called Bob, but there is some stuff about Bob that she's interpreting as beliefs. And so I want to highlight this as like a complicated thing that is happening that is being grossly abbreviated by these little quotation marks.
I just want to name that we're at the hour mark. You can continue, obviously.
Yeah. As before, I welcome discussion. I'm happy to just end on this slide and just talk as much as people want, or I'm also happy to go on. Yeah. Are we gonna like officially close off at some point? Or are we just
Yeah,
gonna
so
go
we
as
have
long
like
as we
a
want to?
2 hour official duration, but we can keep recording even after that, or we can like stop recording in case that makes discussion flow in a different way or an easier way at some point. Personally, I'd be keen to see a little bit more of your slides, and then maybe discuss. But that's just me personally rather than speaking as the host.
Cool. Yeah. So I mean, my next few slides are just like definition after definition. So before we go to the next one, are there any like comments or questions on this one? Okay. So I kind of hinted at this one heavily already. So this belief endorsement thing seems like it's fairly straightforward kind of adaptation of the reflection principle. Oh, by the way, this term endorsement, I want to credit Scott Garibrandt for giving me a better term than reflection. So we can make the sort of obvious generalization from beliefs to expectations. As I argued before, expectations are just kind of generalized beliefs. It's just like a probability is an expectation of a 0, 1 variable, and this lets us talk about expectations of variables with broader ranges than that. And so here, V is a random variable, and omega, little omega is a particular world out of capital Omega, the space of worlds. And then omega tilde P is a world sampled from P. And this gets us like a little bit closer to being able to talk about decision theory, since now we could consider in particular V that are like giving us the expected value in some sort of preference system. But of course, not that much closer, because we still aren't talking about decisions. I want to be able to talk about like endorsing a decision, not just some kind of generalized belief. So for the next definition, I need to introduce the concept, which I'll call here a selection function. My notation is like a little different than the post at this point, but not very much different. But a selection function S, which is intuitively like I'm selecting from a number of options. It takes a belief in the form of a probability function, and then values that it's trying to optimize in the form of an objective function U, and then a set of possible choices C. So here I'm making U be of the type from C to R. So it takes a possible choice C and gives us a ranking R of it. This is a little funny, but we'll modify it later. Just as P represented an agent's belief and E represents its expectations, S is trying to represent some kind of choices, but choices indexed by beliefs and values. So a particular S should be thought of as an algorithm that's agnostic to these beliefs and values, but which takes these beliefs and values and then makes a choice. And the simplest case of S is to imagine that it's just the argmax function for U, but this isn't always realistic for bounded rationality, so I want to consider more general cases. And then we can define what I'm calling selection endorsement, which is agent 1 having beliefs P1 and a selection function S1. Selection endorses agent 2 with beliefs P2 and choice S2. That should be selection function S2 as optimizing U2 if and only if, and then we have a formula that's analogous to what we had before it, that if we knew the choice that Bob made, if Alice knew the choice that Bob made, and if Alice was trying to optimize Bob's values, then Alice's choice, given the same options, would be the same thing. So Alice endorses Bob's selection as optimizing Bob's values given Bob's choices, even on Alice's own beliefs. I should clarify this notation is, so when I put the C and then the bar and then a proposition of some kind, what's actually being conditioned is the probability distribution. So you're imagining this proposition being fed into Alice's beliefs. Since S could do this job optimally by just being argmax, the probability distribution here really plays kind of a lesser role than you might expect. So, like, it wouldn't play any role at all if we had unbounded computational power, because we would just select the option which has the highest utility. but we imagine that there might be like many more options than we were able to efficiently look through. And so we have to use approximations. And so the probability distribution here really only feeds into these approximations. So this probability distribution is really just logical uncertainty in some sense, or just bounded rationality, whatever term you want to employ.
Is that an assumption or a fallout? Why can't the conditioning reduce empirical uncertainty?
It's because of the way that I defined U as already giving us a score given an option. So we can think of U here as a pure function of our options. Like given an option, there is a true score given by U.
Yeah, that makes
Um,
sense.
and this is why I've secretly called it selection endorsement rather than something else, because I'm trying to codify this. Oh, where's a good slide for this? Well, anyway, yeah, I'll just talk. So, okay, so I have this post called Selection versus Control, in which I argue that the sort of things that people name optimization fall really into two different clusters. Some of them are selection style optimization, and some of them are control style optimization. So selection style optimization includes like mathematical optimization, where you're given some possibly complicated objective function and you're trying to produce a particular element of the landscape that gets a high score on this objective function. And if only you could just check every individual case, you could compute this argmax and just give the best thing. And this is why I'm saying, well, this is selection endorsement. This is mathematical optimization. This does not really include any optimization under uncertainty or empirical risk in the classical sense. The only risk is because we we have some mathematical subjective estimate of like what the best outcome is because we aren't able to search over the whole landscape. So we have our kind of empirical subjective probability distribution, but only because we have to estimate the shape of the landscape from checking a few points or things of this nature. And then the next definition I'm going to give is for this notion of control optimization, which is really more what people typically mean when they say words like agency, where we really do have some empirical uncertainty, or a different way to put it is our preferences depend on the world, things that we don't have access to of the world, not just the selection that we make.
It's not quite clear to me. Well, so for example, suppose we have a thermostat that has like some fixed temperature that is supposed to maintain, or like
Yeah.
some more complicated control system. And I know very little about control theory, but my impression is that, yeah, you can basically program these things using not that complicated mathematical optimization methods, and they feel very control-like to me.
Yeah. So I definitely want a thermostat to count as control in this dichotomy I'm making. My argument for that classification is, although a thermostat may be mathematically simple in itself, and it may implicitly like be crafted in a way that depends on a relatively simple world model that we can optimize. And assuming that world model, it's actually exercising optimal control. So it is in some sense the policy is a result of mathematical optimization. But the thermostat is supposed to control the real room temperature, which depends on the actually quite complicated world, right? So a thermostat is best viewed as control because the thermostat is trying to sort of plot a course through reality in which the temperature of the room is maintained to within certain tolerances. And that reality itself is not some simply described mathematical optimization landscape. Does that make sense?
Yeah, so it would, so it seems like a selection, it's like locally when an optimizer at any given time step makes a decision whether like to raise or lower the temperature, it's like a bit simple and selection-like, but because it's embedded in this larger reality, and effectively it's maintaining the temperature within certain narrow range, it's better viewed as control-like optimization.
Yeah, and in fact, the reason why I'm providing both of these notions of endorsement is because I think there's fruitful ideas translating between. Like, you can take a system and view it as a selection process or view it as a control process and gain some fruit from doing this. So it's like, I'm note that I'm starting to lose my voice. So if you're like most control processes are in fact designed by making world models and selecting actions which are optimal under the world model, right? Or at least attempting to do so through some approximation. And so most controllers are actually implemented as selection processes. But I think that aligning the difference between these two notions of optimization is nonetheless an important mistake. And part of my hope here, like, I wrote this selection and control post. I didn't have any mathematical formalism like this. So part of what gives me hope here is like, yes, I'm like finally like articulating some nice math behind these distinctions I feel intuitively are quite important. Like I articulated this distinction because I felt like I see a lot of AI papers that just like don't make this distinction and are as a result making important mistakes. Of course, that's a more complicated point to argue than the more empirical idea that there are these two clusters. Okay, so now we want to define control endorsement. In order to define control endorsement, we need to change the type signature of U. So I will define decision functions analogous to these selection functions, which take objective functions, which are functions of both the choice from the choice set and the way the rest of the world turns out to be. And so, like, yeah, this type signature is a little bit fishy, but maybe I'll let somebody else comment on why. So then D given U and P and C can be thought of as optimization under uncertainty, trying to actually have some kind of impact on the world rather than just optimizing some selection based on sort of intrinsic criteria to that selection. Or at least we can think of it as optimization when it satisfies the criterion of control endorsement, which again is just the same shape of formula again, but with appropriate letters substituted. So why do I bother to define, well, I already talked about this. Why did I bother to define selection endorsement before control endorsement? Well, I think lots of interesting things seem better described as selection, such as gradient descent. And my intuition is that there's useful ideas by translating between these two views of a given system, like saying, this neural network was selected by gradient descent type selection processes, but that selection process was for the purpose of implementing an actual real world impact. So we also can put the control view on it, and maybe we can get formal fruit out of translating between these things. If Alice control endorses some act of Bob, it isn't as if some grand mathematician in the sky handed us C, U, and P. I want to emphasize that these are, again, parts of Alice's world model. Alice noticed this choice set C as a relevant variable in the environment. Like Alice is in the passenger seat, Bob is in the driver's seat. Alice thinks of Bob as having several different ways that he could steer, several different routes that he could take. This is like an empirically relevant variable in Alice's world model. And again, I think the formalism kind of maybe obscures this, and so I want to call it out. In general, I feel somewhat awkward about some of my type choices, and I think that there's room for improvement in this whole theory. Some further refinements to think about. The way I've defined objective functions, U goes against my intuitions expressed in my essay that I mentioned before, an orthodox case against utility functions. I'm using these like rigid functions instead of these expectation operators that I'm more interested in. And also, of course, I've assumed that beliefs are represented by probability distributions. That might be a bit naive, might not give us like enough of a bounded rationality perspective. It might be better to replace them with maybe something like logical induction, maybe something like infrabayesianism. There's different generalizations that we could consider for a variety of reasons, but yeah, I've got some more stuff, but I notice my voice is getting pretty hoarse, so I'm going to beg to end the talk there and do some questions.
Yeah, thanks so much for that lovely talk. Feel free to just, I guess you'll want to keep your screen shared, or just in
Yeah, I
case
mean, I might
someone
scroll
has a
around to
question.
various slides.
Cool. Well, feel free to
And
jump in.
is there a way that I should share these slides, by the way?
I'll have to check with Dushan about that.
Okay.
There might be a way.
But of course, the details are also in the post of the same name.
What is the Skirms, the paper by Skirms you mentioned when discussing value chain?
Oh yeah, I should have. Okay, what's the? Gosh, I'm not remembering the name off the top of my head. The paper by
I got it
Skirms.
somewhere. Hold on. Here it is. Diachronic coherence and radical probabilism.
Cool, thanks.
I'll try to find a link for it.
I appreciate it.
I have a question around, well, the whole talk, I guess. Would you say, is it accurate to say that this is a movement away from AI control to AI trust and then formalizing trust? Is this some texture of your shift or your movement?
I agree that there's some texture of that there. Yeah, I'm not sure what to say about that other than what I've already said. But yeah, I agree that there's some flavor of that.
Yeah, well, there's like two things I want to ask. I guess that was more of a contextualizing question. One is, it seems like you're talking about the fact of trust, but not the process of coming to trust. Is that accurate?
Yeah, that's true. I definitely hope that there's some outcome of the process of coming to trust, but I haven't really grappled with that yet.
So in like constructing friendship with machines of various sorts, these could be like important anchor points or boundary points in the process. Is that how you're viewing this? Or is that
Yeah, I mean,
too
I think
concrete
we
or too
need to
specific?
understand. I think we need to understand what trust basically is before we understand the process of coming to trust. But
Right.
yeah,
So this would
yeah,
function
I
as
don't.
endpoints, possibly. Like at least some endpoint of this direction would be some boundaries of the process. Is that right?
Yeah, yeah, it's unclear to me how to start down that road.
The other part of the question was like, why? Maybe this is too difficult a question, but like it seems like you want to formalize because we trust formalization, generally, and I can imagine that formalizing it is not the only way forward to understanding trust. I mean, we've had some discussions along these lines, of course, but it occurs to me that you could frame it as, oh, we trust formalization. And then as we come to understand trust more, that might also change. I guess this is a remark for you to remark upon if you want.
Yeah, I mean, I guess all I can say to that right now is yes, I would trust much more if we had a formalism. Like, I don't know how to achieve the kind of level of confidence that we want, given our large seeming concerns about AI existential risk. Um, I don't know how we could achieve the level of confidence without more of a formal understanding. But I do agree that formalism is just like one modality amongst many, that I expect the formalism itself to agree with your claim that like formalism is just one way that we come to trust. And in fact, most of friendship does not involve some kind of formalism. But it's like most of friendship is more empirical, but we just don't know how to have empirical trust in this kind of one shot super intelligence scenario. How do you kind of become friends and gain trust in an AI super intelligence when it seems to be like a special case of everything that we expect to be an exception to a bunch of rules?
Yeah. I guess I do want to dialogue more, but Steve, I see your hands raised.
Yeah, well, hey, Abram, good to see you again. Um,
Yeah,
I didn't follow everything, but you've motivated me to dig in more. I've been meaning to read your post forever, so I'm glad this pushes me more. And I love one thing I did follow is just kind of defining endorsement is where reflection applies. I think that's cool. Like Sahil and I have argued about, like, well, I think some value change processes, like me reflecting and experiencing things, I would endorse, and other value change processes, like getting a railroad spike through the head, I would not endorse. But I guess I didn't. So the end went by quick for me, but I didn't see there. Like, do you have stuff to say then about legitimacy? Like, someone else endorses a process like astrology or whatever that I just don't. And
I
is
don't
there?
really have very much to say about legitimacy. What I have to say about legitimacy is basically I just don't want to leave it out, right? I'm like, legitimacy is sometimes different from endorsement. Sometimes I endorse things and am wrong. sometimes that like we can, if like endorsement is a whole lot like consent, right? And it's like, yeah, there's this rosy picture in which we should be given the opportunity to consent or not consent to like everything that happens to us. But like children are raised by parents and don't consent to a lot of the things that happen during that. And like maybe we want them to consent more, but like probably not like the limit of like they consent to everything, because like that's impossible, and also they would just have some bad ideas that they need to be like taught out of at some point, right? And so we can see from these examples that like something can go wrong where we confuse endorsement and legitimacy, and we think, well, um, we just need to build the AI superintelligence that only does things we endorse. And I'm like, probably yes. Like, probably we just go hard on endorsement, but we need this step where we think about there's this difference between endorsement and legitimacy, and there's mistakes that we make, that we could make, there's missteps that we need to just at least think about a little bit harder, of like where we could go wrong with going too hard on endorsement to the neglect of legitimacy. But I'm also kind of like, if somebody comes to me and says, yes, Abram, you're right, endorsement and legitimacy are different, I have the correct legitimacy, and we should steamroll over everybody's endorsement based on this notion of legitimacy, because this notion of legitimacy is correct, then I'm like, that's probably wrong. That's probably like taking over the world in this sense that Eliezer Yudkowsky suggested people should not do, right? Like paternalistically enforcing your own notion of legitimacy just seems like a generically dangerous thing. So I feel that there's arguments to be made that these two should not be allowed to diverge too much, but at the same time, we need to be aware at least that there is a risk that we confuse the two when they could be different.
I have one more question about, maybe it's not like strictly related to the talk, but I can't resist. Although you talk a bit about like what other things than probability distributions you can put as belief-like things into this formalism. Why do you think that linear logic is a more appropriate formalism for beliefs than sigma algebras?
Yeah. Okay, so this remains very speculative despite years of kind of thinking about this. And I don't want to go whole hog on like linear logic is just the right thing. Like I feel there is something deeply wrong about linear logic as well, but I'll give my argument. So my pitch is like this. We want to understand the like like where does this sigma algebra come from? Or where does the algebra come from? And if it is a sigma algebra, could we justify that? And if it's not, what's the right appropriate thing that we get instead that sort of naturally falls out? And my argument that the thing that naturally falls out is probably more like linear logic than like a sigma algebra is like this. So as many of you may know, I like logical induction a whole lot. I think that it's right to think of like beliefs as not completely coherent, and instead we want to build systems that have these approximately coherent beliefs. And how do you do that? Well, a kind of generic way to do that is with a market, because in a market, any sort of easily computed non-coherence will be pumped out of the market by a trader who recognizes that incoherence and takes advantage of it for a money pump, and thereby gains wealth and at some point has enough wealth that it's just enforcing that notion of coherence. I think that's a great picture. But if we are imagining beliefs as having this kind of type signature of things on a market that can be traded, then the natural algebra for beliefs is basically like an algebra of derivatives. So like we have a bunch of basic goods. Some of them represent probabilities because eventually we anticipate that they take on the value 0 or 1. Some of them represent more general expectations, as I've been arguing. But we have these goods. The goods have values, which are expectations. And then we have ways of composing these goods together to make more goods, right? And I don't have like a complete satisfying picture here that says, it should be linear logic. But it feels like if I imagine goods as these kind of contracts, then like I naturally have like the tensor. Like if I have good A and good B, then I have a contract which is like I owe you one A and one B, and this is like the tensor. And I naturally have like the the short of an object, which is like the negation. So I have like good A, and then somebody wants to short that good. And then I can kind of make this argument for like all the other linear operators, like as like natural contract types. And that's basically my case.
Thanks. I'm personally not very familiar with linear logic, so I will like keep that in mind as I'm trying to learn it.
Yeah, so it's like it's sort of like this picture of like, well, if we put together a prediction market, we can force it to use classical logic if we want. Like that's what logical induction does. Logical induction gives us something that approximates classical probability distributions, but only by virtue of forcing like the market maker is saying, I will allow any trades that enforce the coherence properties associated with classical logic, right? It's like things are either true or false. Propositions are assumed to be like eventually they will be 1 or 0. We assume that there's not some like unresolved proposition, even though logical induction is manufactured to deal with logical uncertainty, which means like there are some undecidable propositions because we're dealing with general propositions in mathematics. And so it's sort of enforcing this classicality with no justification. And so my hope there is like, well, we should think about what falls out naturally from the idea of setting up a prediction market when the market maker isn't obsessed with classical logic. And as I said, it just seems like whatever it is, it seems closer to linear logic.
This brings to my mind like James's how James like showed probably he wasn't the first one to show this, but like how you can like kind of lawfully derive classical Bayesian probability from first principles by loosening some assumptions of classical logic. I wonder whether you could do something similar with linear logic and derive some other version of probability.
There's a paper I like to cite, but I've forgotten the name of it as usual. But I cited in many of my posts. I don't know. But it's like you so it takes the Kolmogorov axioms of probability and it weakens them in a way such that when combined with classical logic, you get classical Kolmogorov type probability. but when combined with intuitionistic logic, you get something that they call intuitionistic probability. And when generally, like when combined with other logics, you get other notions of probability. So that seems kind of close to what you're describing there.
Oh, cool.
Yeah, I should try to find the reference in that.
I saw Yapa is unmute. Yapa, if you still want to ask your question.
Yeah, I found this notion of endorsement potentially very useful, and I was thinking about formalization, and this generalization from a reflection principle to which would be a relation between what someone's perspective at one time and someone's perspective at another time. The generalization to different agents' perspectives. I found that generalization very interesting, and I was thinking during this talk about it. So the reflection principle, it sort of looks like a time translation in the physics sense, and so I was thinking about formalization of this in the sense of the Noether's theorem for endorsement. In Noether's theorem, the correspondence between symmetry transformations and the conserved quantities. And here we have transformations, which are symmetry transformations if there's an endorsement between two perspectives, and potentially some conserved quantity, which would be in the sense of, in the case of probability distributions, a probability in the sense of utility functions, a utility. That was my thought.
So in the
Yeah,
usual
interesting.
in the usual time translation, the conserved quantity is energy, right?
Yeah.
So it's unclear to me why would be probability and utility
No, okay, so
correspondingly.
different transformations does not correspond to different. Okay, so here we have utility functions, we have probability distributions, we have those do not correspond to transformations, but what corresponds to transformations is the relationship between my belief at one time and another time, and my belief and some other agent's beliefs. Those two would correspond to transformations in this analogy. Did that make sense?
Yeah, I guess like one of them is not continuous, right? Like the translation to another agent. So
Yeah.
I don't know if that changes a lot. It seems like
No.
Noether's theorem. No, it doesn't
No,
change.
it's there are conserved quantities for discrete transformations.
Yeah, I mean, I don't know a lot about Noether's theorem, but from my perspective, my model is like the quantity that's conserved that comes out of a particular symmetry is like a surprise for me, right? I'm like time symmetry leads to energy. Okay, I don't get it, but amazing. And like, what is it that leads to momentum being conserved? Or so it's like, from my perspective, I'm like, yeah, I have no idea what would happen under this analysis.
I think the analogy is a shallow one, but I think the math might be useful.
Yeah, interesting.
Yeah, there's a lot of good food for thought this talk. Thank you for the talk.
Thanks.
I also want to make the remark that one other reason that legitimacy feels important is that I can imagine, like in some really sophisticated scenarios, deception works by becoming non-agentic or something. And so like you're trying to maybe put some endorsement bounds or something on some process or some agentic thing, and then it tries to cheat you by making the intentional stance not viable or not relevant or something like that. and then endorsement no longer seems to apply, but it feels like legitimacy could still somehow apply. Like then you aren't thinking about like specifically the agent's beliefs or something, but you're just thinking about what should happen, something like that. Like because it seems like endorsement needs the intentional stance in the first place in order to talk about coherence between two intentional stances, whereas legitimacy might be more general for processes.
I mean, I guess I want to emphasize here that I've purposefully defined several different notions of endorsement, right? So I might endorse something in one sense, but stop endorsing it in a different sense. So, for example, I didn't get to it in the talk, but there's like purely instrumental endorsement, which means like I think that this has a very effective policy, but I don't think of it as having beliefs. Um, and so, you know, there might be these kind of intricate relationships between these different notions of endorsement that mean like the situation that you're describing is like some notions of endorsement drop off, but others might remain.
Yeah, it seems like purely instrumental captures the case that I was talking about. So the quote here just means, why not just write down C given A or something? Like, what does equals, etc. mean? Like, it felt like, so the quotes were internal representations of some message or something.
Yeah, the quotes do seem kind of less significant here, I agree. So maybe, but no, so I'm saying like the event in Alice's ontology can be understood as saying like this random variable A equals a particular value, small a, right? Like Alice is still kind of interpreting the world through the lens of certain random variables, which are not just events in the algebra necessarily. But I don't know. Yeah, there could be different ways of writing it for sure.
That's not clear to me. So, how is it different? So the assignment, I say, the equality does talk about certain events, right? I don't.
Yeah, I mean,
Why would you distinguish? Or maybe I'm not following your distinction.
I mean, there's still a correspondence, right? Like, a,
I think I
if we're
get.
using the formalism of random variables, a random variable is not something that's in the sigma algebra.
Yeah.
A random variable is still a function from worlds to R. And so there's still a correspondence to be pointed out with these quotation marks of like the event that corresponds to these random variables, this random variable equaling a certain thing. But it is a much lighter weight correspondence than the one I was trying to point out earlier with my quotation marks.
I'm still not sure I fully follow, but maybe.
A random variable equaling a certain thing is not an event. It doesn't have the same type signature as an event. It is easily translated to an event, provided that event indeed exists in the algebra, which it may or may not.
Right. I mean,
I
guess I'm not
I don't
saying
want
the
to like
relevance.
super duper
Yeah.
defend,
Yeah.
but there is like some kind of translation there still.
So we might also like address like the question I had, or maybe disagreement or whatever around simulation, like what goes wrong with simulation. And it seems like, again, you might, oh, can you still hear me?
Yes.
It seems like you could say again that simulation will make sure that there's self-endorsement, but not self-legitimacy or something like that. Does that also
I'm not sure what
address-
you're saying.
So it seemed like the thing that would go wrong was that Abram was fallible if I simulated you. And
Yeah.
the fallibility comes from the fact that you endorse a lot of things that we'd be
It
able to
seemed like
capture your
the-
endorsement, but we won't be able to capture your legitimacy. It feels like that's maybe the implicit argument, but maybe not.
There's some kind of like transitivity of endorsement that fails. It feels to me like Abram might endorse like Abram's judgment after thinking longer as better than Abram's current opinion. But if Abram is the judge sitting in this particular location in this broader system that is tasked with giving the thumbs up or thumbs down to particular ways for the larger system to be thinking, like Abram does not think that that overall leads to an endorsable system of cognition, right? Like, I don't think that I'm good enough to be able to completely point out what modes of thinking will result in endorsable versus non-endorsable results just from like thinking about it sufficiently long when those modes of thinking are expressed in a way that might be opaque to me, such as a big neural network.
We have like 3 minutes left in the 2 hours. Feel free to hang around after. Abram, do you have a sense of when you might want to leave?
Yeah, I mean, my voice, I'm still getting over a case of COVID, and I just feel my voice is getting rougher and rougher. So I'll probably leave around the hour mark just for that reason.
Naturally, Abram, my attention was caught by the teleosemantic stuff, but I'll read the post first and follow up.
Yeah, I have a sense that we probably still have like a large disagreement about teleosemantics, but yeah, we should definitely schedule a call sometime.
That'd be great.
Ooh, do you want to say, Abram, something about the subtitle of your talk about the distributed Ponzi scheme?
In 3 minutes. Well, okay, so yeah, I left in this subtitle at Sahil urging me to leave in this subtitle, but I didn't really get to any of the contents that would correspond to this because I had limited time. But so one kind of objection out of a few different objections I've gotten to this stuff is, isn't this just circular? Like, I am defining agency in a way that requires an agent to be judging, and I am defining meaning in a way that requires a system of meaning in the first place to be judging whether there's meaning here. And uh, so I'm calling this a distributed Ponzi scheme to kind of highlight this kind of circularity there is to it. And yeah, in limited time, I guess all I want to say about that is like, I think there's not actually a problem here. I think that the circularity is fine. I think that this is not trying to be like a physical reductionist theory in a certain sense. It is trying to provide coherence constraints, and we are already agents, so it's fine. Like, we are already coming from a perspective which we are judging things from. But I do think there's like a discussion to be had there. I think it's actually quite unclear once you start to think about it, like what kinds of circularity would be problematic versus what kinds are perfectly fine and acceptable.
Okay. Thanks so much, Abram, for those beautiful slides and that lovely talk. I suppose we could try to get a link to the slides under the YouTube video once it's uploaded. Thanks
Oh, okay.
everybody for joining.
Yeah, thanks for
I
hosting.
guess you can stay tuned for the next speaker. I don't have it on hand in the series, which will probably be in a couple of days. I'm sure you'll find it in the usual channels. All right.
All right.
See y'all.
Thanks, everyone.
Feel better.